Welcome to yet another exciting educational video brought to you by Upvision Concepts Academy. So we'll continue under laboratory techniques and safety. We'll be looking at this subtopic, handling chemicals safely. We'll see how chemicals are safely handled in the laboratory to avoid accident, to avoid anything that is disastrous. So it is good for us to know. Inside this video, you'll be looking at introduction. You'll be looking at types of chemical hazards. We'll see general rules for handling chemicals and storage of chemicals, handling spills and accidents. So sit tight and enjoy this video. If you have not subscribed, please subscribe to our channel to get more content. So we'll dive into what we have for today. Handling chemicals is a routine part of lab work. That is, it's something you have to do every time. However, many chemicals can be dangerous if mishandled. If you don't handle it well, then you see that it will come back to hurt you. To ensure you safely handle it and your own safety and that of others, it is important to understand how to store, handle, and mix and dispose of chemicals correctly. So we are expected to know the categories of chemical hazards, safe handling and storage practices, appropriate personal protection equipment, PPE, first aid procedure in case of exposure to accident. Okay, so types of chemical hazard. Types of chemical hazard. Types of chemical hazards. Okay, so you see, chemicals are classified based on potential danger. Okay, so understanding this danger helps us in taking appropriate precautions. So the first one, classification or classification, I would say is corrosive. Corrosive chemicals. This one can burn the skin. Can burn the skin. Burn the skin tissues. Burn the skin tissue. So if it spills, it's not supposed to even touch any of your skin. That's why you have your gloves, thick gloves, and your lab coats. The chemicals must interact with the bottles, with the pipettes, with the burettes, and the conical flasks, the beakers. It does not have to come out from wherever it is contained. So it burns the skin tissues. Yes, it burns the skin tissues. Examples of these kinds of corrosive chemicals include hydrochloric acid. So in the lab, you have the dilute one or the corrosive one or the concentrated one. You have sulfuric acid. You have sodium hydroxide. This one is caustic. Number 2, classification is flammable chemicals, the one that can burn. Flammable chemicals, the one that can burn very fast. Examples is ethanol, and acetone. Okay, then you have toxic chemicals. Number 3, you have toxic chemicals. So these toxic chemicals, it can actually harm or kill when inhaled or when you mistakenly ingest it and it's absorbed. Example of toxic chemicals are lead compounds, and chlorine. Chlorine is also another example of toxic chemicals. Then number 4, classification, you have reactive chemicals. This one easily reacts and it can be explosive. So they react, can be explosive, explode or react violently. Sodium, potassium and sodium, these are metals in the group 1, the left-hand side of the periodic table. Sodium and potassium, very active. Even in the activity series, you see that potassium is top. Okay, so they can explode and they can react violently. And number 5 is carcinogenic. Carcinogenic, I discussed this one in one of my videos. It can cause cancer. These chemicals can cause cancer, so let us be careful not to expose our bodies. Example of this kind of carcinogenic chemicals is the benzene. So you see, when you're in the lab, you're handling all these kind of chemicals. Ensure it doesn't come out from the containing vessel. Ensure that you know what it means. So hazards symbols are used to indicate dangers on chemical containers. So you will see that symbol, hazard symbol. So students that are doing their exams should take notes and ensure they are safe. Okay, so we'll go into general rules for handling chemicals. General rules. Number 1, always read the label before using the chemical. Number 1, always read the label. Number 2, never taste or directly inhale chemicals. Don't say you want to sniff it. No. You can read up the properties of that chemical. Don't use your physical body, your nose, your tongue to actually taste. It has been done. These things has been done already. Then number 3, safety rules. Wear gloves, goggles, and lab coat when handling hazardous substances. Number 4, safety rules, general rules. Use a fume cupboard when dealing with violent or toxic chemicals. Number 5, add acid to water. Never water to acid to avoid explosion. See, acid is more concentrated than water. So if you put water on acid, there will be violent reaction and to explode. So this rule is generally prevalent in our senior school exams. They will say never add acid to water. Never add water to acid. Add acid to water, please. Acid is more concentrated. So the more concentrated one, you add little of it to water, so that water will diffuse it. There will be enough space for it to react. But if you put it that way around, the acid is too much for the water and it will explode. Number 6, do not mix chemicals. Do not mix chemicals unless instructed to. So, like I said, the instruction is always important. Okay. Number 7, keep flammable substances away from open flames or spark. Keep flammable substances from open flames or spark. Number 8, label all chemical containers clearly. Clearly. Don't go and mix up the label. Be responsible. If you have prepared a solution or you have used a reagent, ensure that the label is there. Number 9, work in a well-ventilated area. That's why the chemistry lab, the windows are always open. Then number 10, wash your hands thoroughly after handling chemicals. Even if you are wearing gloves, when you are finished, wash your hand, clean yourself up so that you will not take chemicals out. Okay, so we're going to be looking at storage of chemicals. Chemicals should be stored according to their type. Okay, so I'll just go to the next one. Storage of chemicals. Storage of chemicals. Storage of chemicals. Number 1, chemicals should be stored according to their types. Okay, chemicals should be stored, number 1, according to their types. So you will label acid should be separate from base. Acid should be separate from bases. Okay, so if you have a section where you have acid, label it acid. Different kinds of acids are stored there. I have a section base, label it base, and different bases should be stored there. Okay, so also they should be stored in well ventilated and cool, dry areas. Okay, in well ventilated, cool, dry areas. This way This is where you should try and store chemicals. Number 3, chemicals should be stored in properly labeled containers. In properly labeled containers. Okay, again, with hazard symbols. With hazard symbols. Number 4, away from direct sunlight and heat sources. You know, sunlight and heat source can act as catalysts and act as something that can fuel reactions. So just make sure that chemicals are stored away from direct sunlight and heat source. Don't put it where near you have fire always burning. And finally, you also ensure that it's stored in locked cabinets. In locked cabinets for highly dangerous or restricted chemicals. Highly dangerous or restricted chemicals. Okay. So flammable liquids should be stored in flame-proof cabinets. Oxidizers and reducers must be kept separate to avoid spontaneous reaction. Okay. So so how do we handle spills? We've seen that in a video, but I'm still going to reiterate it here so that it can fall into this particular video of handling chemicals. If, for instance, you have minor spills, handling accidents, we're talking about handling accidents. If you have minor spills, wear gloves and goggles, use absorbents or neutralizing agents for accident spills. So if you have minor spills, just wear your gloves and goggles, then use absorbents. That is, absorbents is like materials, like a reagent. You understand? You pour on that place where you have a spill, e.g., sodium carbonate for acid spill. You are using that one to like neutralize it. Okay. Secondly, if you have a major spill, accidentally you have a major spill, that's maybe a large quantity of chemicals spilled to the ground. What you do is to evacuate the area, make sure everybody leaves that place, then inform your teacher or lab supervisor. So then ventilate the lab and clean under supervision. Clean under supervision. Sometimes the pouring of these chemicals on the ground can start a kind of reaction. Evaporation can start occurring. You know, you see that the smell of the environment changes and is hazardous. So if we have, again, chemicals splash on the skin, rinse with water for 10 to 15 minutes. Then neutralize, example, if you have, use the dilute acetate acid for alkaline bonds. And if, for instance, you have inhalation, that is, you inhale toxic fumes, so move to fresh air quickly so that your lungs can receive fresh air and seek medical attention. Then eye exposure, if your eye is exposed to chemicals, what you do is quickly use eye wash station and rinse your eyes with clean water for at least 15 minutes. Then if you have taken in a chemical by injection, do not induce vomiting. Report immediately to your medical personnel. Okay, so we'll go into disposal of chemicals. It's very important how we dispose them. Okay. So we'll go into disposal of chemicals. Improper disposal can harm people, animals, and the environment. So what are the rules we should observe when we want to throw chemicals away? How to expose it? Number 1, never pour chemicals down the drain. unless approved. Because it is easy to use to look at the sink in the laboratory and just pour the chemical down the drain, but you don't know where that pipe is leading to. You don't know where the pipe is leading to. You don't know whether it's close to. Of course, it should the drain should lead to where human beings will know, but you don't know who will open up that place and everything. So just never pour chemicals down the drain unless approved. Okay. Then number 2 rule is to neutralize acids and base before disposal. Neutralize acids and bases before disposal. Okay, so don't throw acid away as acid or throw base away as base. Before you throw acid away, neutralize it. Mean you put base on it so that it can become harmless. You understand? Or for bases, you put acid on it so that it can become harmless. Don't dispose them in their natural form, because it can also harm somebody. Then number 3 is that we should place waste in properly labeled containers. Place waste in properly labeled containers. And number 4, we should use biohazard or toxic waste bins as appropriate. We should use biohazard or toxic waste bins as appropriate. And finally, we follow the teacher's instruction. Very, very important. Follow the teacher, follow my instruction or instructor's guidance. Follow the teacher or instructor's guidance. So follow my instruction. If I'm leading you in the lab, please, when I say you should do something, you do. If I say don't do it. The teacher is more experienced than you, so that you don't expose yourself to harm. Okay, so we have come to the end of this video. There are questions in the description of this video pertaining this particular topic, questions from the exam, but concerning this topic. So feel free to look at these questions and the answers, engage us in the comment section. Then if you're not yet subscribed, what are you waiting for? Subscribe to our channel to get more of our STEM content. So I hope this video has been informative for you, and I'd like to thank you for viewing.